Hello and welcome to another episode of Flying High with Flutter. I'm your host, Alan Wyma, and today I have a fantastic guest. He is Bastian Gruber, and we talked many times before when I met him before. So he's no relation to Hans Gruber.
Still didn't watch the movie.
Favorite upcoming holiday. Sadly, didn't watch the movie yet. But so if you guys may or may not know, I do kind of run a small little mini-series on the Rustation Station about Rust, and so I had him on the show. And I also asked him if he wanted to come on to the Flying High with Flutter podcast show. Not because he's using Flutter at all. I don't think you've ever touched Flutter in your life, which is fine.
I'm so close to touching it. The next side project I'm going to...
Hopefully... Oh, okay. So then we're kind of getting you all warmed up.
Yeah.
Anyways... The reason that I wanted to bring you on, and we discussed this over email quite a while back, which is there's a lot of discussions about should I use PHP, should I use Firebase, should I use X, fill in the blank, right? And for me, I tried using Firebase. I wasn't a fan of it. Maybe there's a time and place for it, but it's just not for me. Maybe I just needed somebody kind of handhold me through it. But in any case, I wouldn't use PHP. And I wouldn't use Python. I'm actually using a lot of Python in production, and it's just not fun at all. So, but in any case, I'm kind of an aspiring Rustation. But according to John, if I read the book, if I write some Rust here and there, I'm a Rustation. So I guess I can now say I am a Rustation.
Congrats.
Still beginner, still in my first shell. I'm interested in using possibly Rust for a backend, maybe for something that's really, really high performance, something I need to squeeze a lot of power out. And I think that, and again, as I mentioned over the email, right, I'm just going to repeat for you guys, since you guys weren't on the email, you guys in the audience. I think that the two best languages that I can consider to use for backends is probably Elixir and Rust. Elixir, maybe we'll have somebody kind of talk about Elixir backends another time. But this is all about Rust, right? So why Rust is a great backend. Maybe that's up for you to talk about, right? Maybe you can give a quick intro about yourself, and we can talk a little bit more about building services in Rust, because I'm sure you've done that before.
Yeah. So hi, I'm Bastian, and I'm a software developer for the past, let's say, 10, 15 years, and I've worked with Rust now since 2018, and professionally I worked with Rust for about a year on a high performance, large scale web backend. And I'm also currently the author of the upcoming book called Rust Web Development. And I'm writing this with the publisher called Manning. So I got into Rust because I was so frustrated with Node.js. And I'm in Berlin in Germany, and it's easy to pick up the language like Node and I get exposure to projects. I'm a freelancer for most of my life. So it's easy to get a high paying project for 6 months, 8 months, and then you can take the rest of the year off. And this was sort of my main point in picking up more and more JavaScript, since there's just so many jobs out there. So my background is a very pragmatic side. You won't learn from me how to best write a language. I'm not the guy who goes and squeezes out every bit of the performance. I just want to get the job done, earn my money, have fun, and build cool products. So after I got so frustrated with Node, since I go from company to company and they all have the same, I'm a growth pain. They struggle since it's not strictly typed. And then people use different types of third-party Node, modules and stuff, just to fix up the code base. You have to do a lot of working around the language. And it looks always so much different in each of the company. And then I found Rust, and I did a bit of a background check, and I looked at the people where they were coming from, and I saw tons of Ruby people, tons of people I read the books from, or I heard the conference talks, and I saw that they pick up the language. And then I think like the starting point is the community where I was on the Barcelona Rust meetup, and I had a super nice conversation there with a Rust developer, and this sparked me on the cab ride home from the meetup just to start my first meetup in Berlin, and it's called the Rust and Tell meetup. And this was sort of like the start for me to get into the language. And what
was the thing that started sorry, let me cut you off because you mentioned it. Like, what was the thing that really said, I got to get on this Rust stuff?
I talked to a developer, and I think she did a lot of like Ruby. And we talked about, since at the time I wanted to develop like a little server application, or like I'm for like a router. I had a small little router laying around, and I wanted to develop like a little application for it, just to fetch some data like from another server. And I thought, okay, let's try this like with Rust, and I couldn't even get a basic HTTP GET to work in 5 minutes. And I didn't really read into the language, and I thought, this is crazy, like who wants to write in this language? And then I dropped it. But then I saw the people, and I went to the meetup, and she had the same pain, and she said, no, like you have to go through it, and it's a few months of like struggle, but then it's really, really great. And I generally trust people who wrote Ruby in the past. I don't know, like it's just, I can align with their mindset, and I thought, okay, let's give it like a second shot. And just the way that people talk to come into the language, they were sort of like me, like a bit more open-minded. They were not super into the language, or like how you say, like the theoretical part of the language. They wanted to get the stuff done, and they really loved how the language feels. And just the community was very special, since you have lots of people from different, like backgrounds. And I joined Go meetups, I joined different types of meetups, but I never met this mentality I found in the Rust community. And this really sparked the thing of, hey, like that's actually nice. Let's have like a self-help Rust meetup in Berlin just to talk about the language. I just want someone on the journey with me. And this sparked it. And then I looked more into the language, and this is like where I found love and the light at the end of the tunnel.
So there's no going back to JavaScript for you then?
It's really hard. Now I work at a company called Twilio as a solutions architect, which means I see lots of code from different companies. I have to help them implement something, and the majority is written in JavaScript, in either like Node.js for the backend, or in some form of front-end framework. And it's really hard. And I could see the same problems and the discussions, and people use the tools. And I thought, why do you keep in this, how you say, like abusive relationship? Like it's hard like to leave, but I feel like that you got so used to the problems that you feel home in the problems. And I'm not the type of person. I have the problems for a year or two, and if they're not solved, I rather do like woodworking or become a cook. I don't need this stuff in my life if it doesn't help me and it's not fun. So I now see the difference, and I would have a really hard time. It's obviously, if I can't find a job, I will pick up a JavaScript project and maybe try to bring the team like more on the Rust side. But I would have a really hard time to write Node.js again or JavaScript.
Have you ever thought about using, I don't know if you actually can do this, like if you can write a lot of stuff in like WebAssembly and then somehow hook it up to the JavaScript? I'm guessing maybe
I didn't play around much with it, but I think this could be something where it's basically then sort of like a pipeline, and then you can still like write your Rust. But then I think this opens up like another problem. It's the same as to use TypeScript. For me, it's just a fix. It's just like the lipstick put on a pig, or how you say. It's, for me, it doesn't like solve the underlying problem. And but it's interesting, since you mentioned that if you want to, because I think that you mentioned if you want to write a high performance web service, then you would pick Rust. And it's interesting, this is probably the best like the selling point of Rust. But I find that a strictly typed like mechanism, like with them traits and with a compiler, it's actually really practical, and you don't need to use it just for high performance services. You can just say, instead of like Ruby, I write Rust. You have to learn a bit more. You have to go one layer deeper into the computer sciencey world to know why certain failures might occur during compile time. But then basically, I feel like from the syntax and stuff, it's like it looks as good as JavaScript or Ruby.
But let's also talk about, Rust in web development, right? So I suppose we could say APIs, HTTP-based APIs are kind of like web development. Most developers are using this kind of based style. There's no necessarily like, if you're going to do something in Node.js, you would probably choose like Express. But if you're doing this in Rust, there's no real like, you're going to have to go for A. It's just kind of like, well, it's kind of up to you to also assemble your own kit, right? Yeah. So can you talk more about the current ecosystem?
Yeah, so this is hard to say if it's a downside or not. I think it's a trade-off, because like Rust also, or like the standard library, wants to be as small as possible to also fit on IoT devices or something like this. So yeah, there is a trade-off. There's actually no HTTP implementation in the language. If you pick up Go, you can just write like a web server from the standard library. In Rust, not. It's just up until TCP, and then you need the tooling. And for this tooling kit, you need abstractions over the HTTP protocol, you need a server, and you need an asynchronous like runtime for you to be able to start. So these are the three pieces. If you choose a framework, this already sort of dictates you the async runtime for most of the time. And it also comes with a server and an HTTP implementation. So by picking the like Express like version in Rust, so let's say like a framework, there are a few famous ones called ActixWeb, Warp, like Rocket. They already come pre-packaged, but you have to include a runtime. So for example, in Go and in like Node.js, they all come with a runtime. In like Node.js, it's the V8 engine from Google. Go comes like with a garbage collector. In Rust, you have like none of this. So you need to have like a framework which is able to split the work into pieces and put them on a thread, or handle this. I put this expensive like work in the background and I continue with something else until this expensive, let's say, database query is done. And for this, you need something else. And I would say like the standard stack I would recommend is like Tokio as like the runtime, since it's just a huge customer base and active development. And then you have the option between like Warp as a framework or ActixWeb as a framework, and they will already come, or like they ship with an HTTP protocol implementation and the server in the background. So I guess that you have to do two choices of like what to pick.
What about Axum?
Axum is like, I think, like it's rather new. It's maybe a few months old. I think this looks like this is going to be my favorite framework maybe by next year. I think it's just new. It just needs some time to get ironed out, to go through some bugs, which I would use as a hobby project. But at the moment, I wouldn't feel, or like my gut wouldn't feel comfortable to implement this and say, just use this in production, and then I leave the client again. They might have a major change and then they need help again to adapt to this major change. I think it's still not 1.0, it's like 0.2 or something. It's like not that this means a lot, but I think just from the feels of it, it's still a bit soon for a production environment.
Okay. I think I want to talk more about the language, about Rust, right? So let's say that, I'm listening to you right now and I'm thinking, I always want to choose, people always want to choose the best thing, right? Nobody ever says, well, I'll just choose whatever. I don't want to choose the best, because that's what we do. So we're kind of saying, okay, Rust is probably one of the best, if not maybe the best language to use in the back end. And so I would probably choose either between ActiveWeb or Warp, possibly maybe Rocket, but I think you're kind of more of a Warp person, which is fine. But I can't really start using Warp unless I start wrapping my head around the basics of Rust, right?
Yeah.
So the best part is that Dart, which is what powers Flutter, is kind of built to almost replace, or at least in place of, JavaScript. And somebody who's done JavaScript for a while, how can you start to explain how Rust is, and maybe how can I transition myself from, if I know JavaScript, to how I can start writing some Rust? Can you give some background about that?
So the transition path is, I would actually say, of course, like you have to buy my book, but not, I think like it's a practical hands-on after you build enough experience. And I would buy the Rust programming language book just to have it on the shelf. And I would get familiar with like writing a first HTTP GET, like fetch information from a public data API and try to print it on the console. And in the process, you already will face 10 different problems of how it feels like with Rust. You have to know that Rust is a systems programming language to begin with. So it sort of is like C, which like it doesn't have a garbage collection. So like you have to think about like memory management, but not really you, because the compiler will make it work for you. But it will sometimes spit out a message which you have to understand why this message comes. And therefore you need to learn a bit about how does it work to allocate like memory, just to get a bit of a sense of the application. So I would say like read the first 2-3 pages of the Rust programming book, build the first HTTP fetch like data from like an API and make it work. And start to Google some of the answers to jump in and learn how to swim. And after you got a bit of a feel, you have to get used to read like the documentations of the packages and of the language. This was a big jump from me, since I never really read the JavaScript, like the documentations, because the problems were so far abstracted that like JavaScript by itself wasn't the problem. And like the node modules were not really well documented. In Rust, it's completely different. You have to get used to read like the documentation of the crates and of the language and try to get the information out you need. So I would try, like it's hard since the changes come from all sides, and you have to understand, the memory management part. You have to understand the async runtime, and that what does it mean that HTTP is not implemented in the language? And I think in the Rust programming language book, you build a basic TCP server. I think this is helpful. And it's not that you completely have to understand each part of it in depth. You just have to know that these are the pieces, and you don't have to do more than 30 minutes of reading for each piece before you can get started, and then like learn as you go. So I would start simple and build an application, have the building blocks, and then figure out the problems and how to solve them. It might be like a messing first few weeks and months, which I don't know. It's just like what you have to go through to see, oh, wow, this is really, really cool. Which, like a side note, this is also like my point of the book is it will help you to become a better developer. It makes you more, more versatile. I feel like your quality in thinking changes also just because this might be just your second language you try to build production applications with, which will alter your mind and will you just gain more insights. So this first pain phase is needed for you to grow. Like it's good pain. I always say like that there's bad pain and good pain. I feel like this is good pain to go through the process. And after like the first few months, you see, oh my gosh, this is really, really cool.
Actually, I think there's a important part that you and I both know, but I think will kind of blow a lot of people away. And even sometimes when I think about it, I find it a little bit surprising, which is that if I'm writing JavaScript, I could just say async await, right? This async await thing. I mean, it's in JavaScript, right? But now, if you're doing async await in Rust, you have to add in a runtime, right? Maybe we should talk a little bit more about that, because it's not like it is in JavaScript where you have a built-in VM that has the runtime already there. We have to work around something. So it's good to talk about this part, because I think most people, it's difficult for them to wrap their mind around it. And for me, I still feel a little bit strange. It's like I have to bring in something in order to use this. This doesn't really make sense.
This is confusing because to this async await, there are like, three parts, or like two parts, like the syntax, the type, and the thing underneath which makes it work. And in JavaScript, this all comes packaged in one sort of package. And in Rust, just the language gives you the syntax, which is async await, and the type, which is a future. And in JavaScript, this would be like a promise. But that's it, which means you can annotate your code, but to be able to make it work, you need a framework, or you need like another piece of code to actually can transform this so that compiler can do this async await later on, or like your CPU, but the compiler can prepare it so the CPU can do the work like this. So there are two parts, like the Rust gives you the syntax and the type in the language, is in the standard library. And then you need a runtime, like which can be Tokio or Async STD, I think are the two famous ones now. And it's not a lot, because, I mean, there's a lot underneath, but for your code, it's not a lot to do to get this in your language, which might put people off, and they think, oh my gosh, now I have to like maintain the third-party library, and what if they change? And this doesn't feel right. Which I think hold these assumptions back and just go for it and wait a few months until you see, okay, that's actually not bad at all. And this could be a big advantage if the language actually grows much bigger. Now I think it's a disadvantage, because I think for like a runtime to be maintained, you need like way more people than even like the Tokio people have, I think. And for like a second one, I feel like you need 500 more people in the language ecosystem to have actually like the manpower to support more like runtimes. So I think now it's a bit of a disadvantage, but later on, this is a big advantage, because like you're not tied to one model. And like what a runtime does, it goes through your code and sees these async await pieces and transforms them into sort of like a state machine so that the CPU can do the work asynchronously. If this is like enough intro.
Yeah, I think this is a good thing to talk about. Like, so let's just say, I mean, I know there's got to be more than just those two runtimes. If not, then people are definitely starting them up. When would I choose async standard over Tokio, or the other way around?
That's a good question. I asked this a few people. I think they want to be politically nice and say, well, it's really a hard decision. So I come from the outside as like a pragmatic person who wants to ship a project. I don't care too much about the nitty-gritty of the language details. I want to ship a product, and I want to be comfortable that I picked the right like runtime. And for me, the first thing I look is how big is the community and how active is the community behind it. Because if there is a bug in a runtime, I will probably, as a beginner, like won't know that there might be a bug. I won't be able to fix it. Therefore, I I need the manpower behind me for this critical piece of software. So therefore I choose based on the community size and how active it is developed. This might not be the best like choice if you're like a language purist, but then I think you already are way beyond in asking like what is like a good choice. For me, it's a good choice. Is it well maintained and does it have a future? And it's fine. Even if the better like maintained and like the bigger community would be slower or like would be slightly more buggy, I feel like I would still pick like the larger size and the more active community instead of this. I feel like these are my biggest indications. If I choose something for a company, I would choose based on this.
So if you were to choose now, like which one would you choose?
I would choose Tokio because on these assumptions. And in complete detail, it might look a bit different. And sometimes this must be like a pro or a con. But to get them started with, I need to know that the people this company is about to hire are able to work with the stack and are familiar with the stack. And this is just like the most picked one, like wins. It gets like the branding, like advantage. It's just of how it is in the beginning. Like it might not be in the foreseeable future, and in 2 years, like something better might come along, but then it has to be twice as good as Tokio, I think, for people to move, if the move is a bit hard. So I think now, based on the manpower, it's Tokio.
Okay, so I started to assemble my stuff, right? So I read through the book. I have a basic idea of Rust based on my prior knowledge of programming, maybe with JavaScript, obviously, maybe definitely with Dart. I started to kind of work my way around it. I think maybe we should talk a little bit about something before we move on to the next step, which is talking about choosing Tokio, or something else in case you find it doesn't work for you, which is what are the trickiest parts about learning Rust, right? If I'm coming from like JavaScript-y kind of background.
The trickiest part, and I could see this like with a colleague of mine, I built something for him. He is a React Native developer and he wanted to change something. And then he just showed me like a screenshot where he just wants to like work like with a string. And he had to use like the string size and then 3 unwraps afterwards to have the content. And he said like, what the fuck is this? Like, this is awful. Like, why would you do such a thing? So it's to understand that a string is not like a string in JavaScript is not a string in Rust. There are different, like models of like represent this data in memory and how to work with it. This is because it's a systems programming language. It wants to be, like efficient. So it's complex. Like a string is not as simple as it might sound. So to understand like string and string slices in Rust should be your first stop to get so like frustrated. The second thing is to understand option and the result enums, because in Rust there is no like null type or no undefined. It can either be like a value or it can be none. And out of these two, so like, and you can pack your result of a function in an option, and you can say this option has a value or this has none. And therefore, like once you receive a result from an API or from like another function, you have to unwrap this option to see what's in it. And this can result in the beginning because you can just unwrap, which is not a safe way in production to look at something. But in Hello World code, it can end up in like super weird, like looking code. But try to understand, there are different ways of peeking inside this option and how to handle it in a proper way. I feel like these two things should be the starting point in the learning journey, because this explains a lot later on if you play with other libraries. So I've explained the option and the strings. I feel like these are the two biggest ones.
But let's kind of roll back, right? Because I know what you mean by string and string slice. I have a rough idea. So maybe I can kind of talk a little bit about what I understand. Maybe you can elaborate more as a follow-up. But like, the difference between a string and a string slice is that a string slice is immutable, but a string could be immutable because it's pointing to something in the heap, right? It's something like that.
Yeah.
Is that kind of the way I can kind of say?
Yeah. So I tried in my book just to say like a string slice lives on the stack and a string lives on the heap. And some people corrected me and said this is not always the case. So, but like of how to understand this, like a string, it's like a growable data container on the heap, which doesn't have a fixed size. So that you would get a pointer to the object on the heap and you can change this data structure on the heap. Like you can grow it or you can shrink it, whereas string slice, and you will mostly create string slices because it's the two, how you say, the commatas, what is the name of these things?
The double quote?
Yeah, right, like the double quotes. This would be a string in JavaScript, but this is actually a string slice in like Rust, which is a non-growable string. And it has a fixed size. So the Rust compiler knows how big it is, so it can work in a different way while compiling your code. And when you want to create a string, which means you can change it, you can shrink it, you have to use like the string type, and you can create it by doing string : from, and then in the parentheses, you put your double quote text in there. And then, or you can do like a string slice, and in the end you do dot to string, and you have a string again. This also is different sometimes if you iterate over like a string, you can get like different stuff back. Like you maybe get like a character back, maybe you get a byte slice back. So there are many different ways to work with text in Rust. And then you also get into the weeds of ownership and who has ownership of the code. And if you can easily like copy this this data structure. So like once you learn about this string and string slices, you already go down an important like rabbit hole of things you will touch. And this might take a few days or weeks to truly understand. Yeah,
that's a good point, right? So I think the one thing we didn't really talk about is, so string slice, I think that's really important, and it's going to take some time to wrap around your head, so don't worry about it if you don't get it the first time. I'm still kind of wrapping my head around it, but as you can see, I got somewhat of an idea about what's going on. But now the more interesting thing, I think that you just brought up, and I'm surprised you didn't mark that as the first one, which is the idea of ownership.
Yeah.
Anybody who starts using Rust will be fighting the borrow checker, but once you have the idea of ownership down, then life in Rust gets much easier.
Yeah.
And it's kind of like don't fight it, right? Which is usually people say, you should fight to get what you want, but really don't fight it because it's doing something for your own health. I would say. Maybe you can talk more about ownership.
Yeah. So I think I didn't bring it up because if you do like a Hello World application, the Rust compiler gives you such good information of like why it's doing it, that I find the concept of ownership didn't like exist in my head. And therefore I just learned a new thing. And until a certain level of complexity of the code, this is mostly all you need to know. Whereas the string, I had to like remove old skills out of my head and put in like a new set of skills, which I think is much harder. So, and the concept of ownership, it basically, the problem is in a systems programming language. if you create, let's say, like a string on the heap, and you want to have like my name is Bastian, so like the variable a is Bastian, and you want to assign the same name to the variable b, then you can just say b equals a, and you think, great, like now you have two different variables which hold the name Bastian. But if it's a string, like a proper string on the heap, like what Rust does is now it says like the two pointers point to one part of the heap. And if you would remove now the string from the heap, you have to notify both pointers and say, hey, this thing is gone. And so like Rust tries to see, oh, like A just pointed to the thing on the heap and B does too. So A is not really needed in this context. Or like you say that B has the unique ownership of the string on the heap. So if I change B, then the data on the heap is changed and I don't have to like notify 10 different pointers, which then can happen that if B like removes the data on the heap, then A might point to an empty of like null, of like, hey, like this doesn't exist, and this would be a problem. And what other languages do is like the garbage collection, like they go through and clean up all those unused pointers. But in Rust, since it wants to not to have a garbage collection, it invented, or smart people made the choice to have this concept of ownership, where it's always one pointer has the unique ownership of data on the heap. If you do it like with an integer and say A is 7 and B is A, then you would copy the pointer. And then you don't have this ownership problem since this number is cheap on the stack and it's fine. But if you have like a larger data structure, it's too expensive. And yeah. So if you want to pass the data down or like the string down to a different function, you have to have in mind that once you put like the parameter in like this function call, this function then has ownership of this data. And you have to return this ownership back to the caller after you're done processing it. And this can be a bit complex in larger applications. But I have to say this was not such a big problem. It's getting tricky, and then you have the like invention of lifetimes, where you say it's now really hard to see how long which part of the function have ownership over this piece of data. It's not clear for the compiler of how long this data like lives on the heap, so you have to annotate it with lifetimes. And I think this is trickier. But I would even say that you have time to understand it. And again, I'm like a pragmatic person. If I do too many like copies, I'm still having a better time than in like Python or like Node.js or something like this. Don't put the learning off of these types of things like lifetimes, but also don't stress yourself out too much about it in the beginning.
Yeah, I remember talking to somebody else, I think on the Rustation Station podcast, and he said, don't be worried about making copies of stuff, right? Mm-hmm. So although we're duplicating things, it's okay. It's fine. The negligible, it's really negligible in what you're doing for the most part. Yeah. So don't be too worried about that. The most important part is having working code and you getting what you want to get done. Yeah. And of course, save code too, right? Fixing this problem is much easier later on in the future. And that's kind of where references come from.
Yeah, right. It's if you want to design a library in Rust or a crate, these types of ownership and lifetimes might be a bit more crucial in the design of the API. But I think by now there are like enough books and how-tos to learn it in a proper way.
Okay. So,
and each of the language has its quirks. So yeah, this is the thing which might haunt you a bit in the beginning.
Yeah, I agree. I think the borrow checker and ownership is something that'll take a while. String slice. Everybody forgets about this one, but it's definitely something else too. Mm-hmm. There's another one similar for vectors, right? I think this is called a vector and a slice. Is that right?
Yeah. So you can have like a byte slice or a vector. You can get into this quite fast, but then the Rust, like the documentation will help you out if you're actually doing the right thing, what you want to do at the moment. Like it's hard to explain all the different options like you might go into. Like it depends on like what you do. I can highly recommend the website called Axum. They have like a Rust track, and I'm never the type of person who learns a language through little coding exercises, but I found that their track is excellent in learning these quirks. It's really, really good. It doesn't take long. You see the solutions from the other people, and this helps like a lot to come up with Hello World tutorials for strings and vectors and all of this stuff.
Okay. Okay, so let's say I got a good grasp of Rust. I chose my async runtime. Now the next step is choosing which kind of backend kind of framework I should choose. What kind of things should I be looking for?
So I would also first say the size of the community, of how active it is. And you might have 2 or 3 options there, or maybe 4, depending on the size of like the service. If it's just like a small part which never changes in your company, then feel free to try something new because it's small and you can try it out. But I think that you generally have the option between like Rocket, Actix Web, Warp, Axum. I think these are the 4 I would have a look at, because I just know from the community they are well like maintained. I know they have active Discord channels I can ask a question to, and this helps you a lot in the beginning. They all have the different quirks. I was not familiar with their way of thinking. So if you come from Node, you're going to have a bit of a struggle in the beginning to align with the mindset of the framework. In Rocket, I think it's still the case that it's very like macro focused. Like you use a lot of like macros, which you'll have to like and to partly understand a bit. Actix Web is more like an actor framework, although people told me you don't have to use it like the actor thinking. And it's also, I think, the most popular one, the most like used one. And then I'm just a fan of like Warp because it gets enough out of my way. It sort of follows the style I like to look at. And then I think it's Axum, which is pretty new, which solved the problems I had like with Warp, but it's just a bit soon. I think it's published a few months ago. So here, but also to say that most of the time you see the framework in 1 or 2 files, and you have an incoming web or like an incoming HTTP request, let's say, and then you have like the middleware, you activate your like logging framework, and then you pass it on to your route handler. And the route handler is still a spot where you have to make sure to return the right type. Like what does my framework want as a return type here from me? And that's it. And in the route handler, you surely pass it on to some other business logic, where in the route handler is maybe 5 lines of calls. Call this expensive calculation, do a database update, do something else, send an email, and then like return it again. So I feel like that you don't see the framework as much. Therefore, also don't be too afraid that to maybe even change it, because the business logic should, I think, like for 95% be framework agnostic at this point. And again, like there might be edge cases, but you don't have to look at it for so long. I think it's important to choose something which supports your logging framework and thinking, and which supports a good middleware like approach, because you might have an incoming request, you might want to manipulate the data or extract the data until you pass it on to the route handler. I feel like these are the two like most important pieces.
Okay, but I think it's also good to talk about a Rust web framework a Rust web framework is quite different than other kinds of frameworks that I've had to deal with, like maybe except for Express. Express, you have to add in a lot of stuff. You have to build it yourself. But actually, Rust is that way too. It's not so low level. You have to build your own router, though, I would say. But like, there's no database ORM that people say you should use if you're going to be using Warp or whatever, right? It's kind of like you still have to kind of build your own. We can go on and on about this for a while. Like, maybe it's better if we talk about what do you choose and why do you choose it? And like, what would you kind of recommend people to look at if they're going to be building their first kind of Rust service?
Yeah. So I would use ActixWeb or Warp. I feel like they go out of your way the most. And then for the logging tracing framework, I think the standard is now to use a crate called Tracing, which is also developed close to the Tokio core, which I think, it's the choice, not like the standard choice. It gives you structured logging. You can do JSON outputs. You can do file outputs. You can do different things. For an ORM, I think there is a thing called a diesel, which is more of an ORM like mindset. You can also use SQLX. And I forgot, I just read today about it. There is sort of like an ORM wrapper like around it. I forgot the name now, which then you can use SQLX, which is pretty pure SQL. But this gives you like a wrapper like around it. So, and depending on if you are a fan of ORMs, you have Diesel, I think, which is not asynchronous supported currently. I might be wrong. I haven't really
This
caught
is
up
correct.
yet.
This is what I've been hearing. Yeah, but I think they have no plans to support it either, if I remember correctly, which is interesting.
Yeah, I don't know the reasoning behind it. I think they mentioned that. Yeah, I don't know. Maybe it's a good question. I don't know why. I'm not there yet at my book, so I will probably go into detail then after my research. But so you can see that you already don't have so many more choices. I think like the standards are pretty much there. You have with SQLX, I think is the standard. You have tracing as the logging library as the standard. ActixWeb as the most used web framework as a standard, with some smaller frameworks too. And as I mentioned, I think, like the community is not big enough yet to support so many different frameworks, which might not be bad, but I think some people want more options, but they forget that these options have to be like maintained, and I think like the manpower is just not there yet in the community.
Yeah, I think so. Okay. So I think that's a pretty good kind of introduction, at least, to maybe people who are interested in using something that's different, or maybe I forgot what. Like, if you were to say like why somebody should be using Rust for their backend, for their services, why do you think they should use it?
I would say now, after seeing it like a lot, like the first reason for me is the type system and the compiler. Don't even think about the performance or the speed or something, because if I want to convince a person who is doing like Node.js applications, it already like runs fine. No company fails because of the tech stack, really, or like most of the companies don't. The problems are mostly, like my code is unreadable, it's unmaintainable. This freelancer came and did a mess, and now I have no idea like what they did there. I think the type system, and therefore just think about that you can refactor code, and the compiler will to 99% tell you where something went wrong. And you have the type system, which is super nice to extend and to read and to deal with, that I think like the quality of your code in the long term, and therefore also like the fun to work like with the code base, is so much more. And don't go too much on like Twitter, like, and read like the arguments about unsafe code and safe code and is Rust faster than C++ of all of this stuff. I think companies who make hundreds of like millions and like the tech stack is PHP, and it almost like falls apart. For like 90% of the companies, like the tech stack really doesn't matter this much. If they're so big, they just rent a new server and they're fine. Like they just want to earn money. Like it's not that they, like Go or like Rust or something. But for you as a developer, you will have more fun with Rust. It's really fun after like a steeper onboarding. It's really fun to work with the language. You have a nice community. You have lots of, like Discords and meetups. You can ask like the questions in meetups. And so it's a super nice and fun environment. And you have a really strong language to support you in your day to day. I think these are my main points why I would use it. If this wouldn't be the case, I don't care like for most part about speed. So what then I use, I don't know, like Node.js still, or like I use something else, like it works fine. But then like the nice part is that you have the option to boost. It's like you have like a mini street car and a camper van and like a speed car in one car. It's like amazing that I can buy a car and I can go to the grocery store and find a parking spot. But I can also go on a 2-week-long camping trip. But I can also do like high speeds on the highway, all in one car. And I choose of like which part of the language I will focus on. And this is for me unheard of. And it might not be on all edge cases right, but it's a super nice language just to get into and use it for yourself. And then the outcome is also a robust code base for the company and for your future colleagues. So I feel like this is the main part people should focus on, and don't get sidetracked by the 10% of people or like the 1% of people who are on Twitter and on like Reddit and arguing about stuff. This is not the majority. This is not the base of the developers. So just play around with the language, see of like, why is it fun? Join a local meetup group, and you will see that it's fun and good.
Yeah. Okay. That's good. Okay. I understand. I think you're not the first person who's actually come out and said, listen, the type system in Rust is just fantastic. That alone is really, really worth something. And I think that makes sense. I think I love the fact that exceptions, aka panics in Rust are really small and not used so often as exceptions are in other languages.
Yeah.
Cool. Is there anything else you'd like to say before we start to sign off? Maybe promote something.
Yeah, I can promote my book. It's not that I want to earn like the money from a book. I don't make much of the book. It won't be my income stream. I don't care if you get your book from somewhere else. I don't care. I want to write a book to help you to get out of the struggle of your current toxic programming language relationship. If you feel like that you struggle in your day-to-day because of the language, this book is for you. It's very pragmatic. I don't waste time in explaining like the details of the language. And like there are so many more people who can do like a better job than me at this. It's like really to get you started. But I also don't just have like the code there. I always try to show the code of how it works and how it feels like. And then I like explain why it is. I explain like the runtimes. I explain string and string slices. So I give you also like the groundwork to understand why a certain thing has to happen. And then you can dig deeper on your own time if you choose to. But this book is a very pragmatic view on how to get started. And it gives you an additional layer underneath in understanding why certain things has to happen in this way. I also go through the way of, I think I'm just done, or like the chapter 4 was mostly like this. I start and I show why the compiler will fail like at this part. And then I go through like the messages and I explain how to solve them yourself, of how to think through these messages and where to get an answer from. So I really start with like the newcomer in mind. And after the end, you've seen so many things and have a base knowledge of stuff that you can choose a direction where it's needed for you to go deeper. So I think it's a good pragmatic book, like which should help you to get started.
Yeah, I definitely bought a copy of the book. I'm pretty happy with it. I haven't had time to go back to it, but what I read so far actually inspired me to start working with Rust on web services. Just so happens that there was that From Zero to Production book that was much more far ahead, so I switched over to that one.
Yeah.
But still haven't finished that one either, so I'm always the guy who starts a book and never finishes.
Same here.
I think we're all like that.
Yeah.
Thank you so much for making time and coming up on here. I wanted to tell the audience that we will be having a giveaway of a copy of your book. So you'll have people be able to win a electronic copy of your MEEP. So your Manning Early Access product or something.
Right. So you can pre-read the book online and then get the paper version.
And you can complain to the author before he publishes if he's not doing a good enough job. But in general, fantastic book. I'm happy that you can come out again. We could chat again. I haven't seen a new version come out yet.
I think Chapter 5 was released. I think after we talked, Chapter 5 was released.
Okay.
Yeah. I think 2 weeks
talked a while
ago.
back, so it could have been
3 weeks ago or something. Yeah.
Then that's just on me because I'm too busy to go back to it.
Yeah.
But I'll be getting back to it for sure. I'll be having more time soon. So I'm happy to get back to it. Again, I highly recommend if you are interested, stay tuned. We'll be getting out a copy of the book thanks to Manning, who helped us to get connected. Otherwise, if you get a chance, get his book. Subscribe to Manning. They have a daily discount, and sometimes they have big sales, so you can get a book pretty cheaply. And also, if you want to get a copy of the book, I highly recommend you buy it straight from Manning and not from like Amazon or these other places, because he will get a higher percentage to himself. So it's not about I'm trying to skimp out to Manning or something. It's about supporting the author.
Yeah.
And so I think that give him a couple bucks, or you can just reach out to him directly. Maybe buy him a coffee, or he's in Germany, so buy him a beer. Maybe I don't know what
this
he's
would be
into.
better. I'd rather have a beer than a book sale.
and you're on paternity leave right now, so I'm sure you can use lots of beers.
Yeah, for sure.
All right. Thank you so much for coming on.
Thanks.
We should probably catch up again once your book is released and maybe talk about the process and everything.
Sure. Let's do that. Cool. Thanks for having me.
Thank you.